Hello, everyone. My name is Pierros Ntelis, and I'm an independent researcher at Aix-Marseille University. I would like to take this opportunity to warmly thank the organizers of Cosmology from Home to give me the opportunity to present my research in this modern way of doing conferences. My research interests are theoretical and observational cosmology, and today I'm going to talk about new avenues and observational constraints of functor-of-functor theories. So in the first part of my talk, I'm going to talk about the recently published paper of myself and one of my collaborators named Functor of Functions. And basically, you can see that we can construct new mathematical entities that lead us to new kind of predictions about the universe, such as the scheme that you see next to you, where we have a cat that tries to pass through a room, and then depending on the configuration, it creates some new kind of fluctuations, the so-called actionic fluctuations, which are the analogs of energetic fluctuations. In the last part of my talk, I'm going to talk about extra dimension, and more specifically, I'm going to talk about d time and dx extra dimensional manifolds with n-point correlators of n target objects with and without contaminants, a paper which is currently under review. And this basically can be quantified in a specific functional, which is the functor of contaminants, bias, and growth of structure. So the outline of my talk is the following. I'm going to discuss briefly what other theoretical cosmologies are building nowadays. I'm going to talk about functor-of-function theories. I will discuss a guide to build models of FA, and then describe the new predictions of axionic field fluctuations, give some simulated constraints. And the last part of my talk, I'm going to talk about the extra dimension in d time and d spatial space manifold with n-point correlator functions for n target objects, give you a generalized formalism with and without contaminants, and apply that to large-scale structure. Of course, you can read the document for extra information, such as application of quantum field theory. Finally, I will conclude and give some outlook. So currently, cosmologists, they build theories within the cosmological gravitology framework. And in the heart of this framework is general relativity, which is a unique theory of massless gravity. Now, we can extend this theory by breaking some assumptions of that, either add some field or add some massive gravity. Now, the most popular way is to add some field, and this can happen by adding a scalar field, a vector field, or a tensor field. The most popular one are the scalar, and they are generalized by Hordensky. Now, if we break some assumptions, we can think of extra dimension, break the assumption of isotropy and homogeneity or locality. Now, this is what have been built by other cosmologists. And in this new paper, we have discussed functor of functions, which is a new way to construct theories. Basically, if we have this equation for a simple action where it is considered an integral of some hyperspace of extra dimension, and L is the Lagrangian energy. Basically, most of the theories, they have been considering what can be done within the integral, while we're considering things, how we can build the S part of this definition of actions. Now, let's see, what are these theories? Basically, a functor is the generalization concept of a functional, and a functional is the generalization concept of a function. Now, on the other hand, the physical quantity action S in physics is a quantity which is the product of energy with time. And action is a quantity which tells us the amount of possible ways a particle can travel from one point to another within a certain region. Now, the new idea is functor of functions, which predicts the existence of axionic fluctuation and field particles, which is the existent analog of the energetic fluctuation and field particles in nature that we are all familiar with. And basically, this can be done by having an integral of all possible actions that we can think of. And this is a subset of all the different type of mathematical entities that we can consider of functors. And therefore, we built the set of functor of functions, basically. Now, how we can build such entities? We can think of a simple integral for an action of effective field theory, which is taken like that, or this integral can have some kernel or some functional of the action, f, and another functional L, or even tensors, tensorial actions, where we can contract them and then build some appropriate action that we can use to describe reality. Now, let's see how this type of actions have some limits, the actions that we have already been discussed. In the document, you can find simple calculations of how these functor of functions, basically, they end up to GR, Hordensky inflation, effective of field theory of large-scale structure and strings and so on. But here I'm going to give you some examples. Regarding GR, you can see that we can have an integral from 0 to S, and S can be considered in the limit of GR that this is equal to general relativity action. And therefore, the sum becomes basically a series of two actions, where we have the first one is the curvature action and the matter action. And you can see here the usual formalism that we use in order to describe the GR action. Now we can do the same with strings. Basically, we have the same integral, and in the limit that this action becomes a string, basically, we have this type of action, which is built by the usual Polyakov formulation. Of course, you can pause anytime and read the text or actually read the document. Now, how we can build new kind of theories? A prediction of modification of Feldstein field equations coming from functor function is the following. I take the usual curvature action, SR, and I modulate it by a beta parameter, which is a parameter that describes a new fluctuation of this action that we were describing in nature. And also we can add another parameter here, which fluctuates basically the action of matter. And I can add also another action, which describes a new type of phenomena of action, the actionic field, basically. Now, how I can do that? I use the usual variation principle, the least action principle. I do my derivation, and I end up to the modified Einstein field equations, which looks like that. On the left part, I still have the Einstein tensor, including the cosmological constant. And on the right part, I have the usual term, which is the stress energy tensor, modulated by some beta parameter, the one that was modulating the curvature action, and some fluctuation of the Lagrangian, which corresponds to the fluctuation of the action, hence the axionic field fluctuations that I discussed before. Therefore, this type of new theories, by doing some appropriate modification of the equation, predict the axionic fields. Of course, I can go a step further and actually build this Lagrangian tensor, which describes the Lagrangian fluctuation, and I can describe it by definition as a parameter, which models the Lagrangian fluctuation, and a 4x4 matrix that only has the stress, the energy density on the time-time component, and the rest elements are 0. And this gives me the new stress energy tensor that looks like that, which means by definition, I have connected the W equation of state with the Lagrangian fluctuations. So whenever we do constraints on W, basically, we constrain the Lagrangian fluctuations. Therefore, if we have deviations of the equation of state, basically it means that we have Lagrangian fluctuations out there. Now, a step further would be to consider quadratic terms of the action, such as the following. I take the action of curvature, and I add the quadratic term corresponding to action of curvature time a beta component. And beta parameter there would be just a number that can be fed into data. I do my stationary action principle, and I end up to this modified Einstein field equations, where I have the geometric tensor here, or topology tensor, if you will, and then the stress energy tensor is modulated by this type of integral and the beta parameter. Therefore, I can consider this as a modification of gravitational Newton constant, which can look like that. Or I could take that this integral is considered to the stress energy tensor, and I have some kind of geometric consequence on my stress energy field. Depends how I interpret the equations. But then, nevertheless, I have created some new type of equations that can describe reality and can describe the fluctuations that are coming from axionic fields, basically. Now, here I have built a simulation where I'm considering two types of parameters, the physical ones that I'm able to measure, and also the nuisance ones, and also the ones that are coming from axionic fluctuations. Basically, I have taken a very simple exponential model modulated with beta parameter. Then I have my physical parameter 1 and the nuisance parameter 1. And I also have a linear model with a phi2 physical parameter, nuisance 2 parameter, and some other parameter that describes my axionic fluctuations by A. Then I do a simple likelihood analysis, and I can give some MCMC forecast about this model. Now, currently, the universe can be considered as the following action, where I have integrated all of the actions that we have so far in nature. Basically, you can see that this type of action is included to the set of functor of functions. And I have written a simple case where I'm considering only the Hordensky action modulated by alpha h, which is basically a parameter that can have a fiducial value 1. And if there's something which cannot be explained by Hordensky, then if we fit this model to the data, it means that we have to find new type of functionals instead of the usual action of Hordensky. And I also have added another action, exotic action, which is also modulated by another parameter. Therefore, I can describe my axionic fluctuation in different type of ways. This is a particular realization of that. And I can then analyze further these type of actions, and I can consider the Hordensky action that contains all the topological, if you want, axionic part, H2 to 5 Lagrangians, or 2 to 5 actions, modulated by the corresponding alpha parameter. Then I have the sum of all cold dark matter particles, CDM, all the gravitons, all the black holes, the neutron star, NS, gravitational wave sources, standard model particle physics, the Higgs matter field, the strings that we still haven't observed, and also some other exotic type of particles. Therefore, if we fit this model to observational data from the sky and from the very, very small scales, we can constrain the full model and have a description of reality. And if this model doesn't fit the data very well, basically, we can consider more sophisticated functionals, functors, or other mathematical entities that can describe reality. And from this perspective, basically, we interrogate nature of how we can find axionic field fluctuations and or particles. Now let's see a simple interpretation of this thing. Here you can see a cat that tried to pass through a room, and basically the action will tell us how many paths there are for this cat to pass through the room, and there are n. But if I have the same size of room and same size of cat, but there is a blockage in the center, then this cat will no longer pass through every path, and therefore I'm going to have n minus n particles. Therefore, there is a space between these two rooms, and therefore I have an axionic field fluctuation. This can happen also in time, and therefore I can have an axionic field everywhere at any time. Now, here we can consider the following. We are in Europe, and basically we are trying to pass through Europe from south to the north, and therefore there is an axionic field. Now, last 2 years, we were having COVID. There were a lot of regulations, and therefore this axionic field was smaller. And therefore, this means that when we have some constraints, then the axionic field changes with time. Now, in the last part of my talk, I'm going to talk about an experimental setup for extra-dimensional manifold of n-point correlator functions. Here I can describe my experimental setup like that, and then I can have the target manifold and some contaminant manifold. The contaminants can come from early times or high redshifts, or from lower late times, low redshifts. Now, I can build my user observable of my matter tracer by the observable equal to the matter in extra dimension times a function. And this functional is a functional of tension of contaminant factor, bias, and growth obstruction. And basically, I contain here all those terms that include each target and the contaminant of each target. Therefore, what can be calculated is the n-point correlator function of the observable over the matter one is going to be equal to this type of function to the power of n, which is going to contain also all the different possible cross-correlation of all those targets and contaminants that I'm considering on my sample. So here I have done some simple numerical application on a simple space-time where I'm considering 1-time and 3-space manifold with n-point correlators of n target objects. And basically here you can see how this functional to the power of n depends as a function of redshift. With blue, I show the cases with only tracers from 2 to 5 correlators, and with red, there is also a contaminant factor, which is formulated by a simple model of a sinusoidal function. If I have increasing number of correlations, I have increasing functional. If I also have contamination, then my signal becomes higher. But be careful, this is happening only for targets at some redshift, and the contaminants are coming from a higher redshift. Here I want the case of lower redshift contaminants, then the behavior is slightly different, and I encourage you to read the document to see what type of behavior there is. So in conclusion, and some outlook, our current picture can be altered by a functor of functions theories, which can be applied to large scales and quantum scales, predicting actionic fluctuation field particles, and also our reality can be altered by extra-dimensional manifold with n-point correlator functions of Nt-objects for extra dimension, targeted contaminant samples, which can be applied to large scales and quantum scales as well. So all this effort can be happening in order to build all the necessary tools to explore reality from extra dimension and other type of mathematical ways that we can comprehend reality, and therefore I would be very happy to discuss this work with you and see how much we can explore in the future from the theoretical and observational perspective. Of course, there is a continuing ongoing work on testing these theories with several observables in telescopes and try to see if this new mathematical understanding can explain dark energy, dark matter, and then Hubble expansion rate. And I'm open to your suggestions and collaborations. Thank you very much for your attention. I'm very happy to present my work in this conference, and see you soon, talk to you soon online or in person. Bye-bye.